My name is Adam Beauchaine. I'm a graduate student in the Department of Computer Science at WPI, and the research I'm going to be talking about today is called Clustering for Confidentiality, an exploration of unsupervised learning for the security of data assets. So I know that sounds like a big, long, complicated title, but I'm going to get into it with a simple idea. Have you ever tried to do something on your computer at home, an endpoint like a laptop or a desktop, and the computer wouldn't let you? Obviously, that happens to everyone. But it turns out there's a good reason for that when you're an application developer, and the reason is security. A lot of our modern systems today, basically all of them, when we talk about endpoints, desktops and laptops, take place in what's called a single execution environment. And all that means is all of your data assets, programs, applications exist in the same data environment. It means if you can get to one of them, you can get to all of them. And that's very convenient for users. You don't want to have to go digging through multiple areas for your data, but it can be very problematic for security. There are many instances in which attacks on a single data asset can impact a whole data environment because of the fact that they all exist within that one single shared environment. This leads to a one-size-fits-none approach of access control, as we call it. Now you might think, why don't we have multiple environments, multiple data buckets that we can put our stuff into? That way, if something goes wrong in one of them, it doesn't impact the entire system. So if you click on a ransomware link, ordinarily that would impact your entire system, but if we have a properly isolated system, or multi-environment endpoint, as we call it, that would only impact the one little bucket that it's in. It sounds like a good and fairly obvious idea. The challenge is that everyone has run into what assets go where. The traditional solution for this is to put a bunch of labels on our data and assign them to different environments based on those labels. And that works good, but it's also a ton of work, and it's really not scalable for modern enterprise environments that have potentially thousands of endpoints and millions of different data files. So that approach really hasn't gained a lot of traction in modern enterprise computing environments. So what if we had a program to do it for us? And that's where our research comes in. What if we could grab a bunch of information about how a user interacts with data assets on their system, so things like what they type into a program, what program they use, what time they access those assets, and use that to dynamically assign group labels to certain assets so we can isolate them to prevent cyber attacks. And I know that sounds a bit abstract, but to give you a clear idea of what we're talking about, here we have an example, and this is an actual example on real data, where we have one user that has two core areas that they focus on in their email client. They have emails that concern to their role as a landlord, that deal with apartments and rents and tenants, and they're also an energy executive, and they talk about energy demand and relations with the state of California energy. So, and as you can see here, this is a data that we've grabbed from just text data that a user has entered it into an email client. And all that we've done here is put it into a very high dimensional vector and clustered. This has been dimensionally reduced for clarity, but you can see that it already kind of works. We have one cluster that seems to strongly correlate to the this person's role as a landlord, and the other one which correlates very strongly to their role as an energy executive. So the idea is, what if we could scale this up on a large scale with tons of different users and tons of different groups that correspond to their roles? So if a cyber attack were to occur on this user, say for instance they clicked on a phishing link that was associated with this cluster, it wouldn't be able to impact any of these assets here in this cluster. So obviously that sounds desirable. How do we actually do that? That gets into the systems building component of our project that you can kind of see here. And the way we're going to do that is obviously that there's a ton of data that we associate with certain processes or workflows in regard to certain data assets. If you think about editing a Word document on your computer, there's a ton of stuff that goes into that. Buttons you press, words you type, the time at which you access it could be valuable in determining what group that asset goes in. So we're going to grab all of that using a set of libraries that Microsoft Windows provides called UI automation. And we're going to grab, as I said, a bunch of stuff. But the most important things that we're going to take are the name of the asset, the window position of the asset on screen. If you think about it, that could be valuable. We tend to group certain assets in certain parts of our screens when we're working on them together. and most importantly, the natural language text data that a user inputs. A user tends to input the same sorts of words on the same sorts of documents, right? And we're going to throw that into one single large data vector, and then we're going to use what's called the streaming clustering algorithm to do exactly this. We're going to cluster it, and then as new assets come in, instead of having to wait for a bunch of data, we can dynamically assign them to a group and thus assign security labels to that asset. So you can see the full proposed system implementation down here, where you'd have an endpoint environment. We'd have one single, what we call harbinger, or the program that grabs all of this stuff, and it sends it off to a data broker. This is fully networked, so you could do an entire organization with one single data broker that delivers decisions for thousands of endpoints at the same time. We're using what's called a data stream clustering algorithm. That's what allows us to dynamically make these decisions. Instead of having to wait for a bunch more training data, we can dynamically perform what's known as vector space classification and say, here's a new asset this user's working on. Based on X, Y, and Z, we're going to assign it to this group for the time being. And that might change in the future as we get more data. So how does it work? That's the million-dollar question. When we're talking about data set construction and experimental design, our current plans are we want to use a real data set in the Enron email data set, which is a corpus of thousands of emails, and we're going to orchestrate experiments to actually have a user go through and type every single one of those thousands of emails. We're not going to use a real user for this, thankfully, because a real user would probably be me in this case, but we're going to use Seculi, a UI automation tool, to dynamically go through and scan that corpus of data and programmatically create workflows to simulate a user doing daily tasks like writing emails. And you can see here some example output from our program that we would get. We would get the number of keystrokes, clicks, a basic set of workflows here. And what's not represented here is the actual natural language text data that we're also going to grab from whatever program we're currently looking at. And so will it work? That's still an open question, but I think we're very confident with the direction that we're going in. You can see some sort of preliminary results here that I think strongly suggest that we're on the right track. But if we're able to do this, as in perform vector space classification based off of dynamic data from a user's endpoint device, I think it's going to be a very exciting paradigm shift for the future of computer security if we get it right. So thank you very much.